Okay, welcome back to the channel. So this is lesson number 2 on functions, and what we're going to do is have a look at maybe a slightly more difficult function. We looked at some easy ones last time, and then what we're going to do is answer maybe a few more challenging questions about functions, things that are quite common that you'll be asked. And so the function that we've got in this question now is this. So our function is defined as f of x is x squared plus 4x minus 6. And then they put a comma here and given us some weird looking thing over this side. So what is that? Now, a lot of you will panic. You don't need to panic, right? That there is quite simply your domain. So we met domain in the previous video, and domain is just the x numbers that you're allowed to put into your function. And so what does this actually mean though? Well, this r means that x is allowed to be any real number. And so real numbers, if you haven't heard of them, are going to be anything which is negative, so any negative whole number, or any negative decimal, any negative recurring decimal, anything like that. You can put 0 into there as well, and then you can put any positive number as well, so positive whole numbers, positive decimals, positive recurring decimals. So you're allowed to use any of those things that I mentioned as x values for this function. Okay, so that's what that r means. So whenever you see it, don't shit yourself, just think it means real numbers. So anything negative, 0, or anything positive. Now, what we're going to do with our function is first of all write it in this form. Now when you see this, what you need to think is I need to complete the square. So that's what we're going to do to begin with. So we take our function, I'll just write it over here, x squared plus 4x minus 6, and we'll complete the square. So x plus 2 all squared, take away 2 squared, and then minus 6. So we'll have x plus 2 all squared minus 4 minus 6. And if we neaten that all up, we'll have f of x is equal to x plus 2 squared, take away 10. So there we go. We've completed the square, and I've got it in this form now over here. So p is the number 2, and q, although it says plus q here, it doesn't always mean that this is going to come out as a plus. Okay, so again, don't panic. Q is just minus 10. So that's all you need to write. I'll pop it up here as well. Q is minus 10. Okay, next. They've then said to find the roots of f of x. So roots, quite simply, are the values of x for when the function is equal to 0. So all we've got to do now is go and solve this equation where it's equal to 0. So let's set it equal to 0. So 0 equals x plus 2 squared minus 10. And what we're going to do? Well, send the 10 over. So 10 is equal to x plus 2 squared. We'll square root that. So we can say plus or minus the square root of 10 is equal to, let's get rid of this, is equal to x plus 2. And then we can subtract that 2 over as well. So then we'll have x is equal to minus 2 plus or minus the square root of 10. Okay, and now part C. So write down the minimum value of f of x and state the value of x for which it occurs. Okay, so what I'm going to do first is write out my function. So f of x is equal to x plus 2 squared minus 10. Now, they're asking us to find the minimum value of f of x. So what does this mean? Well, this means out of all of the x values that I can put into here, after we sub that x value in and work out the value of this expression, they want to get the smallest possible value that it could be. So let's just do a few examples of x numbers that we could put in. Now, if you think about it, let's maybe sub x as 5 and see what happens. So if we put x as 5, that would be 5 plus 2 squared, take away 10. So 5 plus 2 is 7, 7 squared is 49, take away 10 gives me 39. So quite a big number. Let's see if we can get something smaller than that. Maybe let's try an x value of, I don't know, minus 5. See if that does anything different. So if we go f of minus 5, we'll have minus 5 plus 2 squared, and then take away 10. So that means f of minus 5 is equal to minus 5 plus 2 is minus 3. Squared would give me 9, and then take away 10 would give me minus 1. So that is good, because we've definitely got a smaller number. We've got minus 1. And we're trying to look for the minimum we could get. So can we get anything smaller than minus 1? Well, watch this. If we put x as minus 2, let's have a look at what happens. So if I use x as minus 2, that will be minus 2 plus 2 in the bracket, then squared, and then take away 10. So f of minus 2 is going to give me, in the bracket is just 0, so 0 squared is still 0, and then take away 10, and I end up with minus 10. Now, why is that going to be the smallest number or the minimum value that you can get? Well, because of this. This part here, the smallest that could be is going to be 0. Why? Because whenever you square a number, it always makes it positive. So even if this was a negative number in here, after we square it, it becomes positive. And so all you've got to remember is this. As long as you can make that part 0, you will get the minimum value. So our minimum value here, where is it? Minimum value is going to be equal to minus 10. And now it says to state the value of x for which it occurs. Well, if we needed this part to equal 0, how do we get it to equal 0? That's when x is minus 2. So the value of x for which it occurs is minus 2. Now, just going a little bit further along, actually, in terms of what you need to know, if you were to draw this graph, so that one over there, what you'll notice is it maybe looks something like this. Something like that over there. And if you have a look at the minimum point will actually be minus 2 minus 10. So the minimum value, the smallest value you can get out of there, will correspond to the lowest y value on that graph. And then the x value for which it gives you that y value would then be the x coordinate of the minimum point. So that's just a bit of extra information, but we'll actually see that we'll talk about this in a couple of videos time. Okay, hope that all helps, and I'll see you again soon.